This is the Skin Science Podcast. I'm Dr. Thomas Hitchcock, and here we'll investigate everything skin science and dissect it from a scientific perspective, analyze it from a medical perspective, critique it from a consumer perspective, and give insight from an industry perspective. Welcome back to the Skin Science Podcast. I'm Dr. Thomas Hitchcock, and today we'll be discussing the science behind skin remodeling. And with me in the studio is my co-host and friend, Angela Wilson McDonald. Hello, Angela.
Hello. Pleasure to be here.
Yes, it's always a fun time.
Always. Always.
Well, today, as I said, we are going to talk about skin remodeling. One of the things that I'm going to make sure my microphone is... Are we good, Alan, with the microphones? All right. Okay. All right. We have our wonderful producer director in the studio making sure you guys can hear us. But the thing about this kind of topic is, just as a kind of disclaimer, because we do work for a company where we sell a microneedling device, we do have to make sure that we don't get into any topics that are going to get us in trouble by going off label and such. But the way that we're going to approach this conversation is we're really looking at the science of skin remodeling from many angles. We're not just looking at microneedling. We want to look at it as basically, because there's many ways to skin that cat, if that's, an appropriate...
I think it's
a pun, but I didn't mean it that way.
Talking about skin remodeling.
So there's many ways that we can go about this in the aesthetic office. And some of it's for one reason or another. And so some of them are for more aesthetic purposes, some are for more medical purposes. But either way, we are looking to cause a remodeling of the tissue, which is very different than what a lot of people think of when they are advertising. This, you hear a lot of because it originally was called collagen induction therapy, at least microneedling was. And so a lot of people, you see a lot of advertisements like make new, fresh collagen, which, as you know, irritates me because...
I know that.
Because when you think about what makes up scar tissue, it's also new, fresh collagen. So, it's one of those things where we understand that there's a consumer perception, but it's different than what a scientist would necessarily look at. And I'd love to know what a clinician looks at versus also somebody in the industry, which we are. And so these are the ways I wanted to kind of look at this particular topic. But the way I think that we do this the best is by first kind of defining what is skin remodeling. So I think the way to do that adequately is to make sure we're thorough. And you can definitely stop me if I start getting in
a little too thorough.
A little too thorough.
As I always do, Thomas.
Yeah, so that's something I can often get a little bit on a rabbit trail when it comes to science. But is by defining skin, looking at skin, the structures of skin, and what happens during the remodeling process, why the remodeling process happens. So when we think about the structures of skin, most people have the rudimentary type of layers. You got the epidermis and the dermis. Of course, that's reductive because there are other structures, other layers or other, little kind of nuances to what make up those. But overall, it's the epidermis and the dermis. Then you have our secondary structures like the hair follicles, the sebaceous glands. You have, nerve tissue. You have, what else we got? Sweat glands. But one of the also biggest constituents of skin that most people don't even think about is the immune system. And that's actually one of the most important parts when it comes to skin and how it functions. Yet we often just completely dismiss it and don't even think of that as a skin tissue.
And why do you think that is, Thomas? Why do we forget that component?
I don't. I think it's just because, it's the same as kind of what we talk about when we talk about the microbiome and how people, when they think of skin, they don't think anything of the microbes.
Because we focus as an industry for so long
on the way it affects skin.
Yeah, epidermis and the dermal
So
layer.
when you look at a lot of ingredients and you see the evidence of why it's good for us, it's mostly because they'll say, well, it takes keratinocytes and it causes them to produce this and that gene, right? And so, but what about the immune cells that are prevalent in the skin? How does it affect that? Because those things affect the keratinocytes as well. And those things affect the microbes, which also affect the keratinocytes. And so it's a much more complicated story. And I think that's why. Because it takes things that are very, that people want to be very simple and you have to then ask other questions, and it makes things a little more complicated. That's where we are kind of today, which is we understand, oh, we thought something was very simple. Now we're learning maybe it's not so simple. And I think that's why people are so interested to hear things like our podcast, because it's bringing to light things that they may never have thought of.
Right. Okay. So if you want to take a deeper dive into, understanding the immune cells, and what's the relevance of that? Why is that important to us?
The relevance of the immune cells in the skin is that when we talk about skin remodeling, a lot of that comes, a lot of people think of that happening upon injury, right? When we have a wound healing response.
Yep.
But it's not the only time that the skin remodels. The skin is actually constantly remodeling. Now, it doesn't remodel willy-nilly, meaning it doesn't remodel just for the heck of it, because the living organisms tend to not expend energy when they don't need to, right? They tend to only expend energy when they have to. It's part of kind of just the evolution of how biology works.
Okay.
And so you don't tend to see a lot of biological systems where something happens that's superfluous to existence. And so an example of this is in when you're trying to do bacterial cells and you're trying to put genes in bacteria and such. If it doesn't need it, it'll spit it out. We call these plasmids that. Okay, we got too deep there.
Yep.
Anyway,
I'm falling asleep, so it's always
why,
a bad sign.
So why the immune system? It's because we have turnover all the time because of going out into the sun, and we get some solar radiation that may cause some free radical damage. It may cause thymine dimers in our skin cells. These are all things that cause damage. And so when we're younger, the immune system actually recognizes the damage. And it clears the damage. And we also have an accumulation over time of what's called senescent cells. Now, those you don't have as much when you're younger, but you do have them in some manners. And this is the reason why we accumulate them as we age, is because senescent cells are typically found after a daughter cell, which is differentiated. So we have our stem cells. They make daughter cells.
Okay.
So we have stem cells that become like fibroblasts or keratinocytes, the skin cells that we think about. Well, those cells cannot indefinitely live, right? They also cannot divide and indefinitely divide. We have what's called a Hayflick limit. And you've heard me talk about this.
I've heard you talk about this over the years. Yep.
And this is what happens is every time a cell divides, because after your stem cells have the ability to extend their genetics to keep them kind of pure in a way, to keep them safe by extending the ends of the telomeres. When they become differentiated cells like skin cells, it loses that ability. So every time they divide, the genetics get slightly shorter, and eventually gets short enough to where it's just kind of in danger of things like forming cancers and such.
Okay.
And so the way that the body handles that is that once they get to a certain place, they become senescent. And this senescence actually changes its phenotype. And it starts to produce different types of cytokines that are more inflammatory.
Okay.
And the reason for that is likely that it's asking to be destroyed. It's asking for the immune system to come get it. Because what's inflammation? Other than...
It's aging. I mean, it's the skin aging, correct? Or it's a response to...
It's a response to some
assault.
Some sort of assault.
Okay.
That's telling the body, I need your help.
I need
the
your
immune
help.
cells'
Come
help.
get me. Yeah, come help me. Yep.
So it sends out these inflammatory signals, and the immune system comes and clears it.
Okay.
So that's part of the remodeling process, because when you have a senescent cell or you get a damaged cell and it tells the body, come clear me out, that's part of the remodeling process too.
Okay.
Also with structural parts of skin like collagen, elastin, if that gets damaged, you need to also restructure that. So your body's constantly restructuring. You've heard it when you were a kid, how you're supposed to be supposedly a new person, completely remodeled every 7 years.
Yeah,
I don't remember what
like that.
they would say.
Your cells completely
and I'm
turn
not
over.
And I'm not sure what the legitimacy of that given time period is. Probably is different from person to person.
But it was interesting nonetheless.
But I think like your bones, even at a certain point, because you have, even though we think of bones as like solid objects, they do turn over.
Yep.
And so even the calcium deposits, we have osteoclasts, osteoblasts, they eat and rebuild. So with skin, yes, we have injury as well. So like microneedling or an ablative a procedure or something, that's a different type of remodeling, but it's the same type of caveat. You have inflammation caused by injury that recruits cells to come and fix it.
Okay.
So that's really, I think, why the immune presence is so important for the process of skin remodeling. That a lot of people don't really give it that much kind of thought when they were getting these procedures.
So let me see if I got this straight, because that's, my purpose in the podcast is to break down the science. So what you basically said there, if I heard you correctly, Thomas, is that the skin is always remodeling. We're going to talk about intentionally remodeling during this podcast, ways in which we actually assault the skin, whether through,
Assault.
well,
Yeah.
to injure the skin, whether through procedures, whether through products, to actually create an intentional turnover of the skin or intentional remodeling of the skin. But what you're saying, I think was what I heard you say, is the skin is always naturally remodeling, even when we're younger and not intentionally doing something.
That's right.
There's a remodeling that occurs, and that remodeling is exacerbated by certain conditions like the sun or the environment or health conditions, or what else would you say were the things that as we're growing up, we're not intentionally remodeling the skin through procedures or products that we know of in our industry, but the skin is naturally remodeling. What's prompting that remodeling?
I mean, when you skin your knee.
Okay, so any type of injury.
When you get a bruise, yeah, there's a lot of things, any type of injury. Yeah, the thing, again, the body doesn't typically remodel something it doesn't need to. Now, that being said, when we're growing up, we are growing, right? So a lot of the processes by which we grow are similar to the remodeling process because we're producing more skin because we're getting bigger. We're producing more connective tissue because we're getting bigger. And so a lot of that stuff is process of deposition of things like extracellular matrix, cells, stuff like that. So those processes, it is different than wound healing because you don't have the immune system as involved, right? But the part of deposition of those things, and it's why when we talk about the aesthetic type of procedures, it's important to realize that the mechanism of action by which these procedures actually work, in order for us to get a result that's relatively natural, have to work similar in the wound healing cascade or remodeling process to where normal production of that tissue works. So that's why certain burns don't really heal like normal tissue, chemical burns or thermal burns. Now, of course, if they're microscopic in nature, it's a different story, but typically there's a threshold by which there's a kind of a fine line between intentionally injuring and getting an aesthetically pleasing result and getting something that looks odd or unnatural simply because the body does have a certain line. When you cross it, it's not going to lay down the same tissue in the same way it would when it was creating it in the first place.
And so you can move from actually treating the skin to traumatizing the skin. And there's a fine line you would suggest between the two?
Yeah, I agree. I think that there is. And you can see that, in aesthetics and in medicine, there are procedures that are around even today that while they were being developed, they were used a little bit too robustly or too much. Lasers being one of them when they used to completely kind of resurface the skin. And you could tell that upon kind of the remodeling process that the quality of skin was just not quite natural.
You got some type of positive result,
right?
Obviously.
Maybe tightening, which is what most people wanted.
Because those procedures are very popular, but yet there was something that was a little unnatural at that point.
Yes.
Okay.
And so that's kind of where, again, the fine line, because in our industry, in aesthetics, in dermatology as a whole, it's really about what is somebody coming to me to address, and knowing what the risk and reward or risk and benefit ratio is with those procedures and what you can walk away with. And so there is kind of this kind of give and take when we're talking about skin remodeling. But the other caveat here is that there's a lot, when we talk about reductive science, is that we cannot look at somebody that's in their 70s and say you're going to have the same kind of result as somebody in their 20s, because the way that our skin remodels, although it's built into our genes as far as the cells kind of know where to deposit certain things, there's also the epigenetic markers. And as we age, we talked about how we start to collect these senescent cells because the body cannot remodel. And so we collect these senescent cells.
And that's because the immune cells, essentially, over time,
Yes.
that are tied into that. Okay. So the
Right.
immune cells are helping to clear and clean up.
Right.
But as we grow older, they're less effective in doing so. Is that what I'm hearing?
You are. And we don't completely understand why that phenomenon occurs, but we know it's tied to a type of immune cell called a Treg cell.
Okay.
So Treg cells actually are kind of the police, if you will, of the immune system, especially in the skin, but everywhere. And these Treg cells actually inhibit the immune system from overreacting. So, for instance, like psoriasis. Psoriasis is an overreaction where the body's actually attacking our own tissues. Any autoimmune type of a disease is because our immune system is actually attacking the wrong thing. It's being overzealous.
Okay.
And so, so when we talk about Treg cells, they're the ones that say to the immune system, okay, this is good, this is bad, attack this, don't attack this. But when we're older, we tend to also accumulate Treg cells. And so they tend to accumulate around the follicles and such. And interestingly, that is what we think leads to this accumulation of senescent cells, because when senescent cells are sending out all these inflammatory signals, the Treg cells are saying, it's okay. You don't need to come get these cells. And so that's why and it's kind of this loop of the more that happens, the more that it just keeps accumulating. So there's a branch of research called senolytic medicine, where they're trying to actually produce either peptides or something, drugs, and they already have drugs that do this, that can actually cause the removal of senescent cells. Because the theory is if you can remove all that inflammation from all those cells that are taking up space and causing inflammation, the body will then kind of get kickstarted to actually reproduce and the cells that should be there, which will then lower the inflammation and cause.
So again, the immune cells were taking care of that when we were younger, but that is all slowed down. And now things are changing. Thomas, walk us through, when is that age? I mean, when do we get to that point when the immune cells are no longer working as they did when we were younger, and we have to start being intentional about skin remodeling? We have to start taking action, whether that's through products, whether that's through procedures, what have you. We have to start creating those injuries to get the skin remodeling, because the body's no longer doing it at the same rate that it used to.
Right.
Do you have any ideas about that?
I do, but let me take a real quick step back to what I just said, because I want to put a little caveat on there before I move on to that, which is, we talked about when I said that when you're 20, you can't expect the same results, or 70, you can't. And the reason for that is because you can have, let's say, since microneedlings are a thing, let's use that as our example. So if you get a microneedling treatment at 70, it's still going to have some benefit, right? Because your body will see that there's holes now in your skin, and it will still heal it. The issue is that it may not heal it to the same extent as you would when you're younger. And then you ask the question, why? And it's because you have this loss of ability to be as robust in your deposition of things like collagen and elastin, as I was referring to with my work in my postdoc.
Okay.
Because you're senescent, the cells available just don't have the ability, because they're close to senescence themselves. So in essence, when we take a senolytic drug, and if it works to clear the senescent cells, we are basically remodeling then as well. And we are getting kind of the same type of remodeling we do as we are younger, where it's constantly renewing. But if we get that microneedling result at 70, and we don't have that remodeling happening, it's going to really dampen the overall result. And so we have to be realistic. Now, you talked about aging, and
I do want to ask one question there. But are all 70-year-olds the same?
No, but that leads to your question before.
Okay, perfect.
So basically, when we think about when is that age that we start to lose, and I've heard some anecdotes, I don't know if that's the right word, but little blurbs where they say you lose 1% of collagen every year after 30. Yeah. And I can't find for the life of me where that comes from.
Oh, okay.
So I'm
just
assuming
made that up, huh?
There has to be somewhere it came from. But it's one of those cute things that people latch on to, and it's a good way to sell them.
It's simple. It's a
but I don't know if
simple
it's
way
true.
to, okay, but maybe not backed by science.
Right. And
Okay.
I mean, I'm sure there's a little bit of truth that somebody took and they just made
Because
it
everybody's
more.
different. Every human is different in terms
Yeah.
of health or exposure or,
Yeah, but
right?
yes, you're completely correct because we're all genetically different, right? So we
Hmm.
all are going to have some differences in our genetic predisposition to either having healthier skin or and we're not going to get into acne today, but we did talk about acne
Hmm.
on our last episode, and there is genetic predisposition to inflammation, which can be corrected by other means epigenetically. But it's the same, I think, with just remodeling. I think there are genetic predispositions, but there's also corrections to that through epigenetics. And so when we talk about when that starts happening, the aging process where we start to collect senescent cells, it probably is around the same time that, you know, everybody notices their skin around the 30s, early 40s.
Start noticing the aging process, the
Right.
changes, the little changes, the fine lines, wrinkles
The
start to
change in skin
appear, a little
texture,
sagginess starts to
jowly.
appear.
Now, that being said, you did allude to that not every 70-year-old is the same. And the
Right.
reason why that is true is because we don't all age the same. And we know that researchers like David Sinclair
Hmm.
and Huberman and not Huberman, David Sinclair and I'm trying to think of the other person I'm thinking of, but I can't. Anyway, these researchers are looking at our genetics and seeing what is it that is causing aging and how might we actually reverse aging, if possible. And the answer is it is possible. And let me give you one major example of how this is possible
Okay.
because they can take a differentiated cell. Remember, we talked about that's a cell like a skin cell
Okay.
that is no longer a stem cell. It has become differentiated. And typically we thought that's one direction. Once you've become a differentiated cell like a skin cell, that's what you're going to be until you crap out. So you're
Okay.
going to make a lot of baby cells and then those will crap out eventually. And so you need those stem cells to make additional cells when those crap out.
Okay.
But there has been research that shows that you can put differentiated cells into certain conditions in the laboratory and cause them to regress back into stem cell states.
Okay.
Now,
Really reversing the aging process at that point.
right, because once you're a stem cell,
Reversing or slowing or stopping?
no, that would reverse because
Reversing. Okay.
remember when you revert back to a stem cell state, because we have to think about why if we have if all of our cells are aging, we couldn't have children because then they would be born old if all those cells
Okay.
were old.
Yeah.
So there's a process which our body actually maintains the integrity of the cell of the genetics. And so we have to then the question is, what about our genetics changes in these differentiated cells that these stem cells don't have this problem? And it has to do with the methylation of the genetics, which happens over a while through metabolism, through insult or assault, as you call it. But it's also the way that it wraps around what we call histones. So there's these little molecules or proteins that the genetics wrap around. Because remember, we have tons of genes that wrapped into a very small space,
Okay.
and so they have to be very organized in order to be packed into a nucleus. But the cell has to know where the genes are at any given time. Because if you have to upregulate, you have to completely unwrap the gene, unzip it, and then do all your work to get it to turn into a protein. So when you mess with its ability to be organized, that's when we start to have problems, and that's where we think the aging process comes
Begins.
from.
It becomes visible.
Right.
If we're talking about rejuvenation or
Right.
the skin aging,
Right.
that's when it becomes visible.
Right.
And that's at different ages depending on the genetics of that person.
Well, and the epigenetics
and what they've experienced.
Yeah. So, for instance, going out into the sun, you may be a 30-year-old, but you've been sunbathing your whole life. Your skin's going to be older. So there's, of course, we talk about ages in years, right? So
Right.
chronological years. But when we look at skin aging or cellular aging, we think about it biologically. So based on the lifespan of an individual, where do you feel kind of in that normative scale of, how your cells, the health of your cells? Some people that are in their 40s have genetics that are probably very young, like early 30s and 20s, and vice versa, based on their epigenetics and genetics.
Okay.
Lifestyle damage, all that stuff. Now, interestingly, there are researchers that are looking into ways to demethylate and to turn back the clock, not just by making things back into stem cells, but just by upregulating certain genes that act to do that.
Okay.
And so you've heard of things like resveratrol.
Of course, yeah.
What do you know about resveratrol? Because a lot of people have a very
Resveratrol is, I mean, I think of it in two forms. I think of it as a supplement that you actually ingest that supposedly reverse the aging. And then I think of it as a topical ingredient as well that we've heard over the years has some effect in reversing the aging of the
Okay, I thought you were going to say one other thing.
skin.
I thought you were going to say wine, because that's
Well, you know.
because wine is. I think
I should have said that.
Well, do
yeah,
you
but I'm in
remember-
the industry, so my head goes somewhere else.
of course.
Yeah.
But do you remember back, I don't know,
Oh.
a dozen years ago, where they said 2 glasses of wine a
drink-
day?
Are we not supposed to still be doing that?
Actually,
Because I upped it to 4 just in hopes that would be even.
No, a
just
study
kidding.
just came out that kind of basically squished that.
Oh my
Now
goodness!
they're saying that wine isn't
How
good for you.
disappointing.
A glass of wine a day isn't good for you.
Okay.
Because I believe like the amount of resveratrol in a glass of wine is negligible.
Right, which is why supplements became prevalent, and then
Yeah.
topical ingredients as well.
Yeah, and so
So what about resveratrol then?
well, resveratrol is a molecule that has been shown to activate. It's also an antioxidant, right? And so we
Okay.
know there's a lot of great, even in skincare, there's a lot of great antioxidants. One being vitamin C, which everybody will pay a lot of money if they get a good vitamin C. The
Topical
problem
vitamin C,
is that
yep.
vitamin C is a very sensitive molecule. So a lot of people have spent a lot of time and research trying to make it more stable. Resveratrol is also an antioxidant, so putting it in skincare can have an antioxidant effect, but we don't think that has anything to do with why it turns back the clock. We think it's
Okay.
more about, I believe, again, David Sinclair is the one that really kind of champions resveratrol, which I don't
I
think
didn't know
it's,
that.
yeah, I don't think it's like as big a thing as it's made out to be, but it definitely is one of the things, because he's shown it, you know, no questions asked really, that it upregulates the sirtuin genes. That's one of the things he researches. And these genes, and it's not just him that came up with this. There's some labs in Japan that showed that you can basically have a certain amount of these genes that if you upregulate or turn these genes on or off, you can basically cause backwards aging in a sense.
Okay.
And so these sirtuin genes are kind of closely related to what does these things. What does this anti-aging benefit?
And he's talking about resveratrol, ingesting it. He's talking about supplements, or is he talking
Well,
topical
yeah,
or both?
no, I think he takes it as a
Okay.
supplement. He also takes other things, like he's big on NAD, which is a molecule that basically fuels the mitochondria, and so by taking that, you're supposed to be energizing your cells and such. And there's a lot of more technical aspects to why you take that.
There's, in other words, there are supplements that we could take that could affect our genes.
Yes.
And over time, our genes have, as we age, there are genetic changes
Right.
that occur, and those lead to aging. But yet, there's something that we could be doing to change the genetics.
Right. Now we have the ones.
Am I simplifying it too much?
You're not simplifying. I just want to make sure that we're being clear that you're not changing your actual genes.
Okay.
You can't really do that unless you
Right.
have gene therapy, which was something that I was working on at one point, and it's still happening. Oh, by the way, this is completely unrelated but amazing. They just did gene therapy in 2 children that have Tay-Sachs and basically have more or less healed them from that. My stepmother's 2 children died from that, so I've been following that for years. Amazing. Anyway, that was a huge rabbit trail.
No.
But yeah, you can't change your genetics. But you can change your epigenetics, and you can change damage
Define
to your
epigenetics
genetics.
for our
So
listeners,
epigenetics
Thomas.
is where basically the things that affect the expression of your genes.
Okay. There you have it.
So even just cytokines can be epigenetically changing the upregulation down, like retinoids. Retinoids change the expression of genes, which then changes the way that the skin works. So
you don't
produces
change your
less.
genes, you change the expression of
Right.
the genes, how they react,
Yes.
or what they put out.
Yes.
Okay.
Or whether they're upregulated or downregulated, which
Okay.
means if you make more of a gene product or less of a gene product. And that'll change, for instance, when we produce less oils, it's because we've turned off certain genes and turned on certain genes.
Okay. So there's something you could potentially do in terms of expressing genes that could upregulate the production of oil again, for
That's right.
instance. Okay. Okay.
An example of that is we know that C. acnes, which is a normal skin commensal that we lose over time. So as we age, we see less C. acnes on the skin. But C. acnes actually has been shown, and that's of course, this is simplified because C. acnes is a species and it's very strain specific. So I don't want to oversimplify. I just want that caveat out there. But strains of C. acnes are able to actually cause the sebaceous glands to produce more oil.
Okay.
So it's kind of a chicken egg thing because we age and we lose oil production. Therefore, it's inhospitable to C. acnes. So we lose C. acnes. But if we can put C. acnes back on, it actually might restart that, and where we can actually kind of rejuvenate the skin through a probiotic means, a legitimate probiotic.
Okay.
And so that's when we talk about whether there's something we can do, part of it is through what we were talking about, like there's also people that are using things like metformin, which is a diabetes drug, but also can crank up things, genes that are associated with de-aging, or I don't know if we want to call it anti-aging or de-aging, because the term anti-aging I think is a little bit
overused. Yeah.
Yeah. What do you think anti-aging means, especially in regards to skin remodeling?
Anti-aging to me says against aging. So to me, anti-aging is more stopping or slowing the aging process,
which is more real what we're
versus
talking
de-aging makes it sounds like you're actually kind of going back in time, which sounds way more exciting, quite honestly.
Yeah, and that's the way I see it too. But a lot of people use anti-aging because I see people poo-pooing the word anti-aging.
Well, it's been so overused.
Yeah, it has. But they say there's really no way to anti-age something. But we're not talking about anti-aging in the sense that it is like antimatter, which is the opposite of aging. We're not talking about it that it's a Benjamin Button type of thing.
Right.
We're talking about it like you said, which is kind of a slowing of the progression.
Right.
Or most of the time, and you can slap me if this is wrong, but most of the time it's used in the sense of disguising aging. So like a lot of hyaluronic acids, they don't really anti-age. They don't really slow aging. They just cause puffiness of the tissue, which hides wrinkles.
Okay.
And
Fair
so,
enough, but I don't know if the hyaluronic acid is considered an anti-aging ingredient.
If you watch some of the marketing.
Okay. All right. Fair enough. Fair enough.
And so I would say I agree. De-aging. I don't know if that's even a word, but maybe we'll make it a word.
Yeah, maybe that's our new thing.
Yeah.
Can we rush off and trademark that real quick?
But let's get back.
I'd like to get back to that. Okay, the person who presents as the first signs of aging. So we'll say 30-ish, and you start to see those first signs of aging outwardly. So you see fine lines, wrinkles, sagging skin, and suddenly we've got a sign, if I'm hearing you correctly, that the immune cells have started to slow down its process of being able to remodel. And now we need to get intentional about what we're doing to help that process. And that's, so now we're going to talk about skin remodeling in the respect of things that you could put on the skin that would help with that process, or procedures that you could do to exacerbate that, to kick off that process again.
Right. And I think one of the things people completely dismiss, not everybody, but I think especially consumers, and you tell me if I'm wrong based on this, but I think they go into a physician's office and they think, I'm going to pay, $500 for a laser treatment or a microneedling treatment, and I better get my money's worth. What they don't understand is that there is no magic wand, and that part of the way that remodeling works is by actually creating an environment on your skin that is conducive to that happening, and in your body too, not just on your body, but in your body. So if somebody's a smoker, doesn't exercise, is overweight, has a horrible lifestyle, has malnutrition, and they get a microneedling treatment, they really shouldn't expect all that great of a response.
Right.
Because
more to it than just stepping in and getting the result, which goes back to that 70-year-old patient as well. It depends on the health of that patient and what they've experienced and what their skin has been through.
And their biological age versus their chronological age.
Right.
And so the marvelous thing about where we are in medicine right now is that we're starting to understand that there are some truly de-aging type of things we can do that can start helping us to at least hold on to the integrity of what we have if we truly keep at it. Just like exercise, you got to keep at it if you're going to keep, the physique that you want and have, because like we said, the body doesn't tend to hold on to things that they don't need. That's why a bodybuilder does not stay that size if he leaves the gym.
Right.
His body will change. And likewise, your skin will change if you change the way that you care for it. Sometimes for the worse, sometimes for the better. And, it's one of those things where we also have to ask ourselves in remodeling as well, some of the molecules that we use and that we kind of lean on for this anti-aging, are we really having chronically? Are we looking at the acute effect and ignoring the chronic effect? And
okay, so what do you mean by that?
so
Give us an example.
I'm trying to think of like an exercise example, but
Are you talking about more acute stress? Or are you talking about more acute inflammation?
both.
Okay.
So when we exercise, another gym analogy,
Okay.
when we exercise, it's often said that you shouldn't overtrain. So that's another thing with bodybuilders is if you
Right.
overtrain, you don't give your body enough time to recover, you cannot gain the benefit, because part of why you get more muscles because you actually cause acute injury to your body,
When you
your
allow the
muscles.
body time to heal, the
It's
muscle
remodeling.
expands,
Yeah.
and then you come back and hit it again,
Exactly.
essentially.
And
Yeah.
that's what happens when you're doing these procedures to get skin remodeling. And yeah, it's not muscle, but it's skin. And it's the same type of effect. It's an acute injury. And then the body's going to see that injury, and it's going to respond as an acute injury, which is different than a chronic injury. So when we think of inflammation, for instance, when we assault, as you said, the body, the skin with microneedling or laser or whatnot, you have an acute inflammation, because inflammation is any time the body
It's
calls
the
out.
first phase of the wound healing
That's
process.
right.
So any of these procedures are triggering the body's natural wound healing cascade.
That's right.
Which always begins with inflammation,
That's
correct?
right. That's right.
And it's just a matter of whether that inflammation is prolonged or acute,
Right.
essentially, as to what transpires from that moment.
Right. I mean, you could get really kind of philosophically granular about that we're always inflamed in a sense if we're always remodeling, because we're always calling for the immune cells to clean things up. It's just the amount of inflammation. It's the extent of
Okay.
inflammation. Now, of course, that's all debatable, and we could talk all day on that. But what the problem is that chronic inflammation, especially, which is in the realm of skin remodeling, what we're talking about here, we know that chronic inflammation is highly associated with cancer. And part of what we think why that is because those Treg cells that we talked about before, actually, when it's chronically inflamed, gets to a point where it starts to say, okay, this is always happening, so maybe we just need to chill out in a sense. But then what happens is then now the immune cells are not there to monitor for the cancer cells when they form. And we're always forming cancer cells. And so when we can't monitor that, it's not a good thing. And that's why we think inflammation is tied to some of the carcinogenesis or cancer.
Right.
And aging
right.
as well. So chronically being
and
inflamed.
other disorders as well, right? Because I'm going
100%.
back to, where I started in the medical industry, which was in pharmaceuticals, and I was working in the cardiovascular market, and that was back in the the 90s when there was a lot of talk about inflammation as it relates to heart disease and heart failure.
Yep.
And it was going back to, there was a lot of talk about C-reactive protein and measuring the inflammation that was in the body. So it seems like inflammation continues to become a bigger story overall in the health of people, and now in aging as well, that chronic inflammation that you're talking about.
Yes, but from the aspect of acute versus chronic, yes, you're right. But we do need the acute version. Like inflammation in an acute sense is very important to the way that we stay healthy. Because we need to be able to react. Our immune system needs to be able to react. It's that balance though, right? And so that's the problem, is as we get older, we're not able to have that balance. And really what we're trying to figure out is, how do we maintain that balance? How do we keep that balance so that we can stay younger? Because we do know that it's possible in animal models to turn mice and such younger based on upregulation and downregulation, demethylation of the genetics and all these things we talked about. The real thing is, how do we do that safely? Because we don't want to turn off the immune system. We don't want to turn off inflammation, because that leads to things like cancer. And so if we can't monitor,
there's a balance.
There's a balance,
There's
right?
a balance.
Like
So the acute is fine. It's
Yeah.
not. It's the prolonged that can start causing issues, which is interesting because coming from the microneedling perspective, one of the things I think that you've helped us see over the years, which I find really exciting, is the fact that the inflammation phase is acute, as long as certain procedures and so forth are followed. And the opportunity that brings in terms of the way, let's get back to that remodeling story, the way the remodeling unfolds when inflammation's acute versus prolonged. So what's actually, talk to us about that, Dr. Hitchcock. What does that look like in the remodeling of skin, whether you do it with microneedling or you do it with other means, in terms of an acute phase of inflammation that starts that process, which we know needs to happen, versus prolonged? What's going to be the end result of those procedures when inflammation is prolonged versus not? Is that really broad?
It is
question?
Broad, but I'll tell you, if it's prolonged, the main results, people aren't going to come back for another procedure.
Yeah. Well, from a patient satisfaction standpoint.
I mean, there's not a lot of procedures where you should have a lot of downtime. Like surgery, you're going to have some downtime. So if you have like a facelift or something, and that's understandable. But I think that most people would agree that there's really very few times where somebody's going to say, we really want you to be inflamed for a really long time.
Well, but there's two different things, right? There's the symptom of the procedure where there's the outward inflammation, but there's also inflammation that occurs in the body as well, right? As a result of some of these procedures, some more than others, correct? It's essentially following a different pathway in the body. Prolonged inflammation is leading to an inflammatory pathway that has an effect on the end result, correct?
It does, but it's not just prolonged inflammation. Like like for instance, if we're talking about whether a procedure looks more natural, like the end result looks more natural versus fibrotic, and you get more scar tissue, that has more to do with the environment that the cells are in.
Talk to us about that then.
So, when we think about like a really good surgeon that can do an incision and suture it up, and then after a while you look at the incision, which I believe you had you've had that experience, and my cousin, who also has some scars from previous traumas, has very, very fine incisions where it's almost very hard to even see if you look at it. Those are great surgeons, and the scars are there. You can still see them. But the reason why they're, you also have people that get hypertrophic scars. You have some very bad scars that can be seen when we have bad surgeons, when something is sewn up incorrectly or was infected during, when it's healing. And a lot of that is because it's really the way in which the environment is, the cells in the skin, the environment that they're in during the healing process, when it kicks off, as well as the remodeling process. If the environment is overall maintained, you tend to see a lot better healing. So that's why if you really match up the skin when you close the skin, there's no real a way for aberrant microbes to get in. The environment is relatively maintained.
Okay, so better from outward appearance, or better if we were to look inside the skin, the healing was better.
Maybe both.
The collagen was different, the elastin was different, whatever it might be.
It would be both, but I mean, even a good scar has a very similar makeup to a bad scar. It's just larger or smaller.
Okay.
Now, that being said, things like microneedling are differentiated from things like fractional laser, simply because you have two different kind of MOs. They're both fractional, right? They're both acute injuries that are surrounded by a very small injury that is surrounded by healthy tissue, which is great because the whole idea is that if you have a micro injury that's surrounded by healthy tissue, you can basically remodel that quickly with very little fibrosis.
Okay.
The problem is that when you have microneedling, I guess with microneedling it's not a problem, but when you put a needle into the skin and then you pull it out, you're not removing any tissue.
Right.
You're just basically puncturing the tissue, similar to like if you...
causing the injury to trigger
that
cascade, trigger the inflammation that kicks off a cascade of events.
Right, exactly. And so, but you're not changing the overall environment.
Right.
That's all the same for the most part. Now you'll get some swelling, some redness, because that's all the hallmarks
symptoms
of inflammation.
Of the procedure.
Right, and it's what we want because you have caused a hole in the skin.
Right.
You do want the body to come and fix those holes. And the idea is that if you create enough of these holes, but that you don't cross the line into causing a macro injury, that you can actually coax the body to remodeling enough of the tissue to give you an overall kind of restructure, better texture, remodeling of scar tissue, all that. With laser, which is very successful, they're probably hand in hand as far as the success rate of things like getting rid of acne scars and remodeling skin. The problem is, though, with lasers, you're actually, either ablating or subablating the tissue and removing a certain amount, or at least killing a certain amount, or coagulating a certain amount of tissue. And although it's very, very small and it's going to remodel quickly and well, The problem is that it's not going to remodel the same because you've changed the environment.
Mm-hmm.
You now have a necrotic, piece of tissue. I shouldn't call it necrotic, but it's a dead piece of tissue that has to be cleared out. So you're not going to have the overall health of the surrounding cells because they're dead. And then you have a periphery which is probably going to die later because it's been insulted by thermal injury. That's not all to say that it's a bad thing to have done. It's just to say it's a different type of injury.
Right.
And so it's more likely that you're going to get a fibrotic type of response with a thermal injury than you would with a mechanical injury, depending on the size and the number of
Right.
and proximity of each micro injury. So that's why with lasers, when we see remodeling with lasers or remodeling with microneedling, we actually can see that lasers and needling basically can have a very similar outcome as far as
Outward appearance.
Result. But you do see that there's a higher instance of things like hyperpigmentation after laser because the modality actually is taking a very different way of causing the remodeling, which can have some side effects.
And it's called post-inflammatory hyperpigmentation because there's more inflammation present, correct?
Well, it's just the type of inflammation.
Okay.
Or it's a type of injury. It's not necessarily, because you remember when we do a mechanical...
Prolonged inflammation?
I wouldn't even say prolonged necessarily. I would say it's just a different. So when we injure the skin mechanically, different genes are expressed as a distress call versus a thermal injury. So there's different types of genes that would actually be expressed in order to react to those injuries. And so heat shock proteins are one of them, which if you look at the surrounding tissue of a lesion from a laser injury, those are going to end up dying because they've been injured. They're not dead yet, but they've been injured to the point where they're no longer going to be viable. And apoptotic cells actually are inflammatory in themselves. So in a way, I guess you are prolonging inflammation because you have that first wave and you would have the second wave. Now that's where it's debatable here. You can get great results with laser, but over time you can accumulate sometimes some fibrotic waxiness in the texture of the skin, which can dampen the ability to soak things in the skin, like great skincare and serums and such. But some people like that because it actually is more tightening than a microneedling treatment would be.
And that's a result of the fibrotic tissue that's created during those particular procedures because there's an area that has to close up, which causes contraction, fibrotic tissue, and causes contraction. Ultimately.
Right, and there are some lasers that are fractional that are very shallow that wouldn't do that, but they also wouldn't remodel the skin necessarily completely. Right. They would just kind of resurface, or not resurface, but like exfoliate, I guess you would say. So there's a range of different ways that you can approach trying to remodel the different parts of the skin, and they're all going to have their pluses and minuses. But the overall thing that is really the cork, or not the cork, but the thing that actually stops from actually getting the best result is age, is the inability to follow your full genetic potential. And that's why when we look at doing these remodeling procedures, we should really also consider the way that we're treating the skin and changing that as well. So if you send somebody home, even if it's your favorite skincare, that may not be suitable, right? You have to look at basically how the skin should be, what environment the skin should have in order to...
As it's remodeling.
It's actually de-age.
Remodeling. And how long, let's say
Which is our
after...
word. We patented that, by the way.
We've already trademarked it. The attorneys are on the phone right now. How long? Let's just say there's a patient goes into a medical aesthetic practice and they have a procedure, whether it's microneedling or laser or what have you. And that triggers the body's natural wound healing cascade and remodeling sets forth. How long is that remodeling occurring post-procedure?
Well, a long time.
Like how long typically?
So a lot of people want an instant result, and some of the remodeling happens quickly. So the epidermis tends to be like on a month cycle, so it will turn over relatively quickly. It'll also like thicken and then go back to normal. But the dermis tends to take a good 3 to 6 months before you're going to actually see a true remodeling. So don't go into any of those procedures expecting a quick result.
Well,
we're almost out of time, so
Not necessarily, because there is the collagen 3 that's present first, right? That acts as scaffolding of the skin, helps to support the skin
like a
as
Band-Aid.
it remodels. But can somebody potentially see results from collagen 3 temporarily being present before the end result, the collagen 1, it actually replaces collagen 3?
Possibly.
Because we hear it, even with microneedling, you hear patients feel that they can see and feel changes in their skin relatively quickly, even though we know scientifically the real changes are going to occur in that 3 to 6 month period afterwards.
Right. And so I guess the end, kind of the final kind of note there is, yes, of course, if somebody feels that their skin looks better, that's really the goal.
Right.
That's really the goal. And so for remodeling, for me as a scientist, I'm more interested in whether skin is, holistically becoming better.
It's
changing.
Right.
And what's driving that versus just simply looking better. Looking better is great, don't get me wrong. But I also want to know that I'm healthier.
Right.
That I'm younger, than I was before. And of course,
that real changes occur.
The real changes occurring.
But the average person is just, let me just feel like something changed here, or see a difference in my skin, or have someone notice a difference in my skin.
And that's what we're going to talk next time about. In the next podcast, we're going to talk about kind of the longevity of the skin, the aging of the skin, and how implications of things that we do that make us look better now, but may not be the best for our skin long term, which can actually age us or accelerate aging and such. So let's put a pin in that because we're out of time. Thank you, everybody, for joining us. Where can they find you on social media?
Social media on Instagram, Angela W. McDonald, and at the Crown Aesthetics headquarters, Monday through Friday.
And sometimes Saturday and Sunday. All right. And here from Media World Studios in Dallas, Texas, this is the Skin Science Podcast, and I'm Dr. Thomas Hitchcock. Thank you for your eyes and ears. We hope you gleaned something from this conversation. If you have any questions, comments, or topics you'd like us to cover, please message me on Insta at dr.t.hitchcock. That's dr.t.hitchcock. And from all of us at Crown Laboratories, remember that skin science is for life. Goodbye for now.
Goodbye, everyone.